Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to arcs and sectors. Arcs and sectors are parts of circles. So as you can see, I have a circle drawn here. We're usually going to go ahead and put a letter here to indicate where the center of the circle is. So when I name a circle, you'll see a little circle, a dot, and then I'll name the circle after it. So this means a circle with center P. And it's really important that we know where the center of circles are because things change whether we're talking about something that touches the center of the circle versus just a random point in the middle of the circle. So I'm going to go ahead and I'm going to draw an angle. Now, of course, the angle is going to intersect the edge of the circle. So I need letters for where the edge of the circle is. So A, B, and I'm going to name the size of the angle, 40 degrees. So angle APB is a central angle. That's the definition of an angle that meets the arc like this. And in this case, it has an area of, or not an area, a size. Measure of angle APB equals 40 degrees. Check. Now we actually have two arcs that got created. And I'm going to go ahead and put a point, random point on here. And it's just anywhere on the circle. We have two arcs. We have the arc from A to B. Okay, so we have arc AB. Now, since the angle is a central angle, the measure of arc AB is also 40 degrees. So that's one of the two arcs that got created by this central angle. The other one is the rest of the circle. So the arc going from A all the way around through C to B. So that would be arc ACB. And the measure of arc ACB is the rest of the circle. So circles have 360 degrees. So to get the measure of this arc, we would do 360 degrees minus the 40-degree slice that's been used. And we find out this arc has 340 degrees. Now, because this arc is less than 180, this is the minor arc, and this is the major arc. Now, all this information changes if you don't have a central angle. Again, this information is just for central angles. Okay, we will measure them in degrees. And remember, a full circle is 360 degrees. So that's very important to know. I'm sure you guys know that from like thinking about, skateboarding and jumps and things like that. You guys are awesome at knowing just kind of that kind of fun stuff. Or, oh, my car spun 360 degrees on ice. That was bad. All right, so let's pop another circle in here. If you don't have a compass, a rough circle works. So I just want to make sure that we have a better circle for your guys' viewing purposes. And it must have slipped. We'll finish. There we go. So we'll do center of W. So circle W. X, Y, and Z. Okay, so what is the measure of arc XZ? If you said, well, it matches the central angle. The angle is a central angle because it has center, and its middle is in the center, hence the word central angle. So it matches 115 degrees. So what is the measure of XYZ? Okay, so to go ahead and get that major arc, we're going to go ahead and say, well, if 115 degrees has already been used, we're going to go ahead and we're going to take 360 degrees. We're going to subtract that 115 degrees off, and we're going to find out that that's 245 degrees the other direction. So basically, your arc measure in degrees. I'm not asking about the arc length. That's something different. The arc measure is going to be equal to your central angle. So whatever your central angle is the number of degrees in your arc. Okay, so if that's your arc measure, what is an arc length? Okay, so I've drawn two roughly concentric circles, and I want to talk about the difference between arc measure and arc length. So I'm going to go ahead and put the center on here, and I'm going to draw a line out and a line up. Now we know, no matter what, this is 90 degrees. This is 90 degrees. So in both cases, our arc measure was 90 degrees. But you can think about this if you've ever been in a marching band and you've come to a street corner and you've had to turn the corner. If you're the person close to the corner, you almost have to like march in place so that your line can stay lined up. But if you're a person on the outside of the corner, it feels like you're almost running to stay caught up with the rest of the line. So this right here is definitely a lot bigger. Or if you run track, think about that. Think about the person in lane 1 versus lane 8 going around a corner. So your arc length, how far you'd have to run, changes depending on, so this would change depending on the radius. So while this is in degrees, this is going to be in units of length. Centimeters, meters, inches, things like that. Now, instead of memorizing a formula, we're going to use proportions, part to total. Now our part is going to be the arc, and the total is going to be a full circle. Okay, so I'm not doing it necessarily just for the 90 degrees. That was kind of a specific. So we would have our arc measure, however long that was, compared to the full circles, 360 degrees, right? Now we would have our arc length, now who remembers a formula to find the distance all the way around a circle? If you said 2 pi r, you're correct. Okay, perfect. And these have to be proportionate, which means they have to be equal. So part to total equals part to total. If you can do a proportion, you're a rock star at this. Otherwise, we have to go to science class and scale factors and things like that. So we're just going to use proportion. Okay. So find, oops, that was a weird, find the arc length for central angle (150 degrees) and radius of 4 centimeters. Okay, and a lot of time arc length, they call it S. Now, I will tell you there is a formula for arc length, but it uses a different style of angle measurement. And we'll talk about that here in a minute. But just like we have radius or Celsius and degree and Fahrenheit, we have more than one way of talking about angles. And we will actually talk about that here in a second, so don't worry about it. So here's my circle. I just want to highlight what we're finding. So 150 degrees, there's 180, so we'll estimate it to be right here. So what they're asking us to find is how long is this? Not in degrees, because they said length. They don't want it in degrees. We know it's 150 degrees. They want it in centimeters. Okay. Well, we know a full circle is 360 degrees, or 2 pi r centimeters. Okay, and I wrote a fancy S so it didn't look like a 5 or something. That's why I wrote like there. We know that our arc is 150 degrees, and we're trying to solve for it, so I'm just going to put an X. Now, think science class-wise, the degree label is going to cancel the degree label, so we're going to need a centimeter label to match up with the centimeter label. So it makes sense that our arc length is in centimeters. So we can ignore our variables by now because we know that our answer is going to be blank centimeters. So we've canceled the labels so that we don't have to worry about them. I'm going to leave it in terms of pi. Always leave it in terms of pi until the last step, only if they ask you to round. So we're going to do cross products. So 150 times 2 times pi times 4 equals 360x. Okay, now I'm not going to type pi in the calculator. I'm going to type 150 times 2 times 4. So this is 1200 pi equals 360. See how I'm treating pi as a variable? I'm going to divide by 360 to get the x by itself. Ooh, let's make that a fraction. So 10/3 pi equals x, or this is the same thing, 10 pi over 3. Now, if I wanted to, could I times that by pi? Yes, now I can, which is approximately 10.47 centimeters. Okay, if you can do the proportion, you've got this. That's all it is. Sorry, my cord's getting in the way. So we found out that if you only do a part of the circle, you will have gone 10.47 centimeters. Just so you know, the full circle is 25. So we haven't even gone halfway, which makes sense. 150 degrees is not halfway. So kind of use a little bit of logic and keep in mind if it's not halfway, you can't have too much. So I said that a formula does exist, okay? Well, the formula is that your arc length equals your radians times your radius. Radian, what is that? Okay, so just like 32 degrees Fahrenheit is 0 degrees Celsius, or 1 inch is approximately 2.54 centimeters. 1 radian, you don't want to know what 1 radian is. However, radian is based on a circle with radius 1. And so that's kind of where we're coming from with this. So let's think about this. You have a circle, and the radius is 1. Not necessarily 1 inch, 1 meter, 1 whatever, it's just 1 unit, generically. And that's the whole point really of radians, is so that we don't have to have labels. Radians are not labeled, so if you ever tell me an angle without a degree sign, I actually will assume it's in radians. And just so you can see, if you're not careful with your calculator, let's say you're trying to do the sine of 5 degrees, but if your calculator is in a different mode, and we type the same thing in, we get a very different answer. So this is why you have to make sure your calculator and your brain are in the same language, because saying 9 in English and 9 in German, they mean very different things, even though they sound alike. So the same thing here, make sure we know what language we're talking about when we're talking about our angles. 32 degrees in America is cold, 32 degrees in Europe, not so cold, right? So keep that in mind. So a full circle, come back to this. So the circumference is 2 pi r, or 2 pi. So 360 degrees is 2 pi. Well, what would 180 degrees then be? If you said 1 pi, you're exactly right. 90 degrees. That'd be half a pi. What about 30 degrees? Well, to go from 180 to 30, we'd divide by 6. It's 1/6 of a pi. So that's all the radians are. These are all degrees. These are all radians. And I kind of joke with my students that if you run half a lap, you get a pie. Oatmeal cream pie, chocolate pie, whatever kind of pie. It'd make me run more, right? Every half a lap, you get a pie. So if you only run a third of a lap, okay, a third of a lap, keep in mind, there's a full lap, right? You've only run a third of it. Almost a half, not quite. That's 2/3 of a pie. Okay? Because it's 1/3 of the full lap, right? So a third of 360 is 120 degrees. So it's all proportionality. Or we have our scale ratio. Okay? So if you recall, let's say you needed to go from inches to centimeters. So you would say 1 inch is 2.54 centimeters. The inch label cancels out. And you would do 4 times 2.54, and you would get 10.16 centimeters. The same thing we can do here is 225 degrees. 180 degrees is 1 pi, so that the degree label will cancel out. And we'll have 225 pi over 180. And at that time, I usually grab my calculator. I don't, but I recommend students do. It automatically reduces it to 5 and 4. So we'd have 5 pi over 4. That's 1 1/4 pies, right? So half a lap, you get a pi. There's 1. And now we're 1/4 of the way to the next pi. Yep, that makes sense. That would be 225 degrees. So just out of curiosity, a few moments ago, I said 5 radians versus 5 degrees. Now we know 5 degrees is a very small term, but what is 5 radians in degrees? Okay. Ooh, hey, refocus. Okay. 5 radians. Well, we know that pi radians, we're in 180 degrees. So we'll do 5 times 180, 900 over pi. Well, it's not very logical right now, so let's go ahead and divide it by pi. 286.5 degrees. Now that doesn't make sense. 5 radians is 286. Well, remember we said in radians, a full circle is 2 pi's. 2 pi's. Oh, 2 pi's is 628. So 5 radians is almost a full circle, which is why we got such a large angle. 5 degrees is very tiny. So knowing the difference between 5 degrees and 5 radians is huge. Now, when you do look at graphs of trigonometric functions, they're generally in radians, so they can use smaller numbers. Because 6.28 is a full circle. If we're using degrees, we'd have to go out to 360 to get a full circle. They don't like doing that. They like keeping their window between 10 and 10. So that's why generally we use radians when graphing. So that's the relationship between degrees and radians. Half a lap is a pi, a full lap is 2 pi's. So however you want to remember it, whether you want to remember it based off half a lap or a full lap, think of it as your favorite pie. I don't care. Think of it as calzones. Half a lap, you get a calzone pie. Then it kind of looks like the same thing, right? My recommendation is this. If your central angle is in degrees, use arc to 360 equals arc to 2 pi r. This being length, this being measure. Okay? If your central angle is in radians, here I would use the formula. Okay? Again, the formula is your arc length equals radius times radians. And I would leave it in terms of pi as often as possible so that you don't have to jump back and forth. All right, so radius equals 21 inches. Your angle, I'm going to use the Greek letter theta for your angle, equals 4 pi over 7. So right there's no degree sign. That tells me that I have a radian measure. So to get my arc length, I'm just going to do radius, remember that's in inches, times 4 pi over 7. And that's going to give me blank inches. Notice I'm labeling. Okay, I'm not going to type the pi into the calculator. I'm going to leave it in terms of pi. 21 times 4/7 is 12. So it's approximately 12 pi inches, or notice my approximate symbol, 37.68 inches. Okay, what if the radius is 8 centimeters and the angle is 70? Ah, I see the degree sign. That's a proportion. 70 is to 360 as x is to 2 pi r. Okay, so that's really 16 pi, right? So 70 times 16 pi equals x times 360. So I'll divide by 360. And again, I won't type pi in. 70 times 16 divided by 360. Ooh, make that a fraction for me. 28 over 9. So 28 pi over 9, and that was in centimeters. And if I times it by pi, it's approximately 9.77 centimeters. So either way you're looking at it, you can do this. Again, if it's in degrees, I recommend the proportion. If it's in radians, hey, you have a formula for that. Okay, so now we know what a radian is. Now we know what an arc length is. We know what a central angle is. What else is there with this stuff? Well, let's go ahead and draw another circle. So we've talked about arc length, we've talked about radian measure, we've talked about angle measure. So what else is there to talk about here? Well, here we have our angle, right? Our central angle, and yes, we have an arc length. But we also have something else called our sector. Now, while your arc length might just be like the crust of the pizza, the sector is like the entire piece of pizza that you ate. So let's say you ate that entire piece of pizza. How much pizza would you have eaten? That's what we're really talking about when we're talking about our sector. So just like with arc length, finding two ways to do it, the same thing happens here with the sector. So there is, if you're in degrees, we still want to go ahead and use that proportionality. So that's your degree or your arc length compared to 360 equals the area of your sector. And that's going to be compared to the full area of the circle, that 2 pi r. Or not the 2 pi r, the pi r squared. Got to make sure we're comparing it to area, not circumference, right? Or if you're in radians, we can still use a formula. Our formula is going to be the area will equal our radians multiplied by our radius squared, so we're still squaring it, divided by 2. Okay, so let's try that for the same angle, once in degrees, once in radians. So for both of them, we're going to have a radius equals 4 inches. Okay, and we're going to use 120 degrees. Now, if you recall, 120 degrees, that's not even 1 pi. Okay, it's 2/3 of a pi. So we're just going to show that doing it in degrees and doing it in radians is going to result in the same answer. It just depends on which format you're given. So 120 is to 360, as our sector area will be 2 pi times our radius squared. So we'll go ahead, and this is 16 pi, right? So we've got 16 pi multiplied by 120 equals 360 multiplying by a. So we'll be dividing that 360 over. And I'm not going to type the pi in the calculator at first. I'll type it in second. So if you don't type pi in the calculator, you write it in your answer. If you type it in your calculator, you only put it in one spot, right? So make that fraction, 16 multiplied by 120 with a 360 on the bottom. So we can either write it as 16 pi over 3, or if I go back and I type the pi in, that would be approximately 16.75. My brain and my hand weren't on the same numbers. Well, what if we decide to do it radians times radius squared divided by 2? So dividing by 2 is the same thing as multiplying by 1/2 times our radians times our radius squared. Forgot to label that in inches squared. All right, so if I don't type in the pi, 1/2, 2/3, 4 squared. Let's make that a fraction. I get 16 pi over 3 inches squared. If I come back and I do type in the pi, I get approximately 16.75 inches squared. So I'm getting the same thing whether my perspective is radians or degrees. I just have a different approach. So keep that in mind. All right, so what if they don't ask us for the actual sector? They just want us to get a portion. So they might say, find the measurement or find the how much shaded area you have. All right, so let's see a circle. Okay, and everything's going to be based off of, you know, what information did they give us? So center is P. We're gonna have a 5-inch radius to Q. And it's a little small for my angle. There we go. Here's R. This is 60 degrees. And they only want the wedge. What is the area of the wedge? Well, the way that we're going to have to do that is we're going to have to get the area of the sector and subtract the area of the triangle. Now, normally with the area of the triangle, we'd say 1/2 base times height, but what is the base? What is the height? The good news is we had a formula for the area of a triangle when you knew 2 sides in the included angle, and you may be going, well, Michelle, there's only one side labeled here. But isn't it a radius? It is. So we can label this here. So the area of the triangle is 1/2 side, side, sine of the included angle. And you can find that formula in some of my previous videos. So now we have the area of a triangle without doing base times height divided by 2. It technically is, but there's a reason why. Okay, now the area of the sector. They gave us an angle, so we're going to do that with a proportion, right? So 60 is to 360 as the area is to 2 pi, or not 2 pi. Why do I keep wanting to do circumference today? How about pi r squared? Pi times radius squared. Okay. So our big area, that's going to be 25 pi times 60 divided by 360, because when I multiply this to the other side. And then we'll have to subtract 25 halves sine of 60. Now, if you've watched my future videos on trig features, you know that I happen to know, let's go ahead and reduce this, that way we're not typing something so outrageous in. 25 times 60 divided by 360, make that a fraction, it's 25 over 6. So here we have 25 pi over 6 minus 25 over 2 times the sine of 60. And the sine of 60 is a decimal, just so you guys know that. I'm in radians, so I got to switch that back up. Now I can do this. Sine of 60 is a decimal. It happens to be the square root of 3 over 2. And if you watch my one on trig identities with SOHCAHTOA, you'll find how I actually know that is square root of 3 over 2. It's in that video. And so I could write 25 pi over 6 minus 25 root 3 all over 4. But let's be honest, how many of you are going to remember to write that in exact form? Okay, that would be a college algebra type answer. Okay, I get that most of you are going to go, okay, let's just type this in right here. 25 pi times 60 over 360 minus 25 over 2 sine of 60. Close my parentheses because it's a good habit to close your parentheses. And we get approximately 2.26 inches squared. Well, let's just check to see if that answers the same thing, right? 25 pi over 6 minus 25 root 3 over 4. Lo and behold, it absolutely is. So keep in mind, even if they only want you to do a sliver of a little bit, you can take what we just learned about area of a sector today from this video and combine it with area of a triangle from a previous video, and you just subtract the two and you'll get that little bitty wedge. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.